you need to know about how to measure density for what's called an RPA, which is a required practical assessment. This means that it could come up in your exam, in your GCSE. They could ask you about the practical, how you'd measure the density of different objects. And there's a few different ways that we can do it depending on what the object is like. It all comes down to the equation for density though. So if we remember that density is equal to mass divided by volume. And that sometimes the unit that we mostly use is kilograms per metre cubed, but sometimes we use grams per centimetre cubed as well. So we need to be able to find the density of a regular solid. And a regular solid, we're talking about something that is of a regular shape. So two things I'm going to show you are a cuboid, so I'm going to use some stuffing, and maybe a cylinder, so I've got some baking powder. I'm trying to find things at home that I could show you how to do this with. Okay, so for both of them, the way that we'd measure the mass is by using a balance, and then the way that we'd measure the volume, if it's, say, the stuffing, then, so we're talking about something that is a cuboid, we're going to do length times width times height. So let's do that one first. So I've got a box of sage and onion stuffing mix. If we measure the length, we've got 16.5 centimetres, 16.5. The width is 11.5. I guess we'll call this the height, which is 6 centimetres. So if we do that as our calculation, so with a calculator, 16.5 times 11.5 times 6, the volume of this box of stuffing is 1,138.5 centimetres cubed. Okay, so if I wanted to find the density of this box of stuffing, then I need to do our equation. So density is equal to mass divided by volume. And I need to find the mass by putting it on a balance. So ,378 grams. So 378, and the volume is 1,138.5. So if we do this on the calculator, that is 0.33 grams per centimetre cubed. So that's quite a straightforward one. We look at something that's like a cylinder. First of all, to find the volume, we would need to find the cross-sectional area multiplied by the length. So we need to find the area of a circle. So we'd need to do pi times the radius squared times the length to find the volume of this. So pi times, and then whatever our radius is. Now, I could try and do this with a ruler to find the diameter across, but a better way of doing this is by using something like this. So this is a digital caliper, and it reads to, it's got very high resolution, so to a very small number. So if I hold it across here, we can see that it says 53.99, ooh, hang on, okay, 53.80 millimetres. So that would be 5.380 centimetres is the diameter. It's just an easy way of doing it because with a ruler it would be more difficult to do that. But you can see that a tiny change means that the numbers change, because this is reading to hundredths of a millimetre, which is a very small distance. Okay, so I would say that this is near enough 5.4 centimetres. That's what we could say that it is. That's the same precision that we'd get with a ruler, and we need to halve that to get the radius. So the radius is 2.7. And the length we could do with a ruler, which is 12 centimetres. So the volume, if I do pi times 2.7 squared times 12 gives 274.8, so 275 centimetres cubed. So if we do the same again, so turning on the balance, putting on the baking powder, it says that it's 147 grams. So density is equal to mass divided by volume. So the mass is 147 divided by 275 is 0.53. So the baking powder has a higher density, or the tub of baking powder has a higher density than the box of stuffing. We've worked that out here. That's great for regular solids, but we don't always have regular solids. If we take a look at this, this is what we would call an irregular solid. So it's a big screw. It's an irregular solid because it doesn't have a shape that would be easy to kind of work the volume out with this. There's a bit at the end that's bigger. We've got cut out bits all here. So working out the volume by trying to do a method like this would be very, very difficult. So we have to use something slightly different. So what we do is we're still going to use this equation. We're still going to find the mass and find the volume. We're just going to find the volume in a different way. So for an irregular solid, okay, so let's do the easy part first. We'll measure the mass of the screw. So it's 25 grams. Okay, so how we would measure the volume is we do it by displacement of water. So if we get a measuring cylinder and we put some water in the measuring cylinder and it's up to here, and then we add the screw into the measuring cylinder, that screw takes up space, its volume takes up space. So what's going to happen is the measurement of the water is going to increase. And if we look at how much it's increased, how many millilitres, that's the volume of the screw. So the screw has displaced the water, it's moved it out of the way, it's moved it higher, and the difference is the number of millilitres, that is the number of centimetres cubed, that's the volume of the screw. Okay, so I've got a measuring cylinder. Now, you should be able to see a photo of what it looks like. And we should be able to see that the first, from the side, that its starting volume is 80 millilitres, well, 80 centimetres cubed. Okay, and if I now put the screw into it, we can see that it's now 83 millilitres, so 83 centimetres cubed. So its change, the volume of the screw, is 3 centimetres cubed. Okay, now if we work out the density, which is mass divided by volume, so we've got the mass is 25 and the volume is 3. So 25 divided by 3 gives us 8.3 grams per centimetre cubed. So this screw that's now in our measuring cylinder is made of steel. So what I can actually do is I can look up the density of steel to compare this to. It's a bit different with stuffing and with baking powder because there isn't a density that's published somewhere, but for something like steel I can do that. And the true value of steel is between 7.75 and 8.05 grams per centimetre cube. Now the reason it's got a bit of a range is because steel is made of iron and carbon, and so depending on how much carbon you've got in with the iron depends on the density. But I would say, considering that I'm doing this in my kitchen using my kitchen balance, so we're not in a science lab, we're not in a specialist lab, that I would say that this is really close to this value. Okay, so it's quite accurate because it's close to the true value. Okay, and then the last thing that we can do, or that you need to know about, and I'd like you to have a go at this at home, is to find the density of a liquid. Okay, so we're going to use, or I'm going to demonstrate using orange and mango squash. I'm going to show you how to do this, and I'd like you to have a go at water. Okay, and I'd like you to measure the density of water in your kitchen, and then I'd like you to find the true value and see how close you are to the true value of the density of water. So with a liquid, we want to get our balance again. I've got one of these measuring cups. It's got lots of different things. It's got teaspoons, tablespoons, ounces, and it's got millilitres here, which is the important part. I'm going to measure out 20 millilitres on a balance so we can measure the mass. So my balance has been turned on. At the moment it reads 67 grams. Now either I could add my orange juice now and then take 67 off, or my scales have got this button which when I press it takes it to 0. So what I'm going to do is mass divided by volume. I am going to measure the mass of 20 millilitres, which is 20 centimetres cubed, of orange and mango squash. And it tells me on here that that is 18 grams. So with my calculator, 18 divided by 20 is 0.9 grams per centimetre cubed. So that's what the density of that orange and mango squash is. So have a go at the water and let me know how you get on with that, and compare it to the true value that you'll be able to find online. You need to know these 3 different ways of calculating density, of measuring density, and the method of how to do them. If you're ever asked about this, always start off by thinking about the equation. Density is equal to mass divided by volume. And then go back to, how are you going to measure mass? How are you going to measure volume? And how are you going to make sure that your measurements are as close to the true value as possible?